Introduction to circles. When we talk about circles, we need to have a working vocabulary. So we'll go through several definitions before we go through any kind of calculations. So our first definition involving circles is our circumference. And we know that circumference is the perimeter of the circle. It represents a full 360 degrees. And we can calculate in one of two ways. Circumference is equal to pi times our diameter, and circumference is also equal to 2 times pi times r. Diameter. Diameter is the longest chord of a circle. It goes through the center of the circle. Radius is the distance from the center of the circle to the edge of the circle. And our radius is always half the length of the diameter. Pi. Pi is the ratio of the circumference to the diameter for any given circle. And that value is a constant, which is 3.14. And when we calculate pi, we can take circumference and divide it by our diameter. Now our last definition is arc length. An arc length is the distance along the circumference of a circle between the points where two radii meet the edge. Now that's a lot of words, so let's look at a picture to represent this. So we have a circle over on the right. We've got the center of the circle and two radii coming from that center to the edge of the circle. Where those two radii hit the circumference of the circle, the distance from one point to the next point along that circumference is what we consider to be our arc length. And it's dependent on what the angle is that's formed between those two radii in that circle. Radians. Radian is an angular measurement. It is a dimensionless measurement, but assigned the unit of a radian. And the abbreviation that we use is RAD. We don't want to just use an R because that stands for radius. And when we talk about a radian is the ratio of the arc length of a circle to the radius of that circle. So here's our equation. Delta S is the change in our arc length. And whatever the units are for arc length, they have to be the same as the units for radius. So they might be centimeters or they might be meters, but they have to match up. Delta theta is the change in the angular measurement, or the size of the angle that's formed when two radii go from the center to the outside of a circle. And then R is our radius, and again, the units for radius have to correspond with the units for our arc length. We want to relate radians to degrees because we're probably more familiar with degrees than radians. And we're going to consider a circle where we have just one revolution. That means we go around the circle one time. That means our delta S value, or our change in our arc length, is the same or equal to our circumference. Now we know that circumference equals 2 pi r. And we know from the previous slide that our change in our arc length equals our change in our angular measurement times our radius. So what we can do then is we can say, since for one revolution our change in our arc length equals our circumference, we can substitute the second equation in for the first equation, and we get 2 pi r equals delta theta times r. Now if we look, r is on both sides of that equation, so if we divide both sides by r, that cancels out. What that leaves us with is if we look at one revolution for a circle, our change in angular measurement is equal to 2 pi. What's the relationship between radians and degrees? Well, we've got two equations depending on whether we're converting from degrees to radians or we're converting from radians to degrees. So let's look at our first equation. If we're given the angle of a circle in degrees, we would take that value and multiply it by pi, divide it by 180, and that would give us that angle in terms of radians. Now, if we wanted to solve for degrees given radians, we would take the reciprocal of that. So if we're given radians, if we multiply that value by 180 and divide it by pi, that will give us the angle in degrees. Now, if we talk about an arc length that goes clockwise, we're going to use positive values. And when we talk about going counterclockwise, we're going to use negative values. So we want to make sure that we know all of the equations that have been represented so far in a circle. We know the equation for calculating circumference from diameter and from radius. We know how to figure out what the arc length is given the angle or the change in angular measurement, and we know how to calculate the change in angular measurement from our arc length. And we also have an equation to convert from degrees to radians and from radians to degrees. We'll do a lot of practice with these problems tomorrow.